Welcome sa atong discussion this time, no? Last time we have tackled about the equation of motion of a single degree freedom system or structure. And then later on, we try to solve the equation of motion for a system for a free vibration response single degree of freedom system nga undamped. And then we also try to solve the equation of motion sa usa ka single degree of freedom nga system nga giconsider na nato ang damping. Now in damping we have three types of damping. We have the underdamped, we have the critically damped, and then the overdamped. So this time we'll have our example on free vibration response. So this is just a very simple what do you call this? Examples aron mas masabtan nato ang concept sa ato ang free vibration response. Okay. So let's recall no the equation of motion. So as you remember, the equation of motion is equal to the mass times the acceleration plus the damping coefficient times the response velocity plus the stiffness times the deformation is equal to the dynamic force P of T. Or we can simply write this as mu double dot plus c u dot plus k u is equal to P of T. So this is our general equation of motion. As you remember, no? This is the general equation of motion. So mo to siya nga last time kada condition atong ginatry na tog solve kani siya nga differential equation. Now, we try to consider diba the free vibration response. So what is a free vibration response? It is when we set the dynamic force is equal to 0. So this is the free vibration response of the system. Okay. So equation of motion, we have the mass. We also have the damping coefficient and we have the stiffness. So si mass ay dali ra man jud kay na siya. Damping coefficient, we already tried to tackle this one in our previous discussion on the single degree freedom system. So we have the undamped and then the damped condition. This time, dugangan na nato gamay na ato ang pagsabot when it comes to the stiffness of the system. So unsa din ang stiffness? Stiffness is the extent to which an object resists deformation in response to an applied force, di ba? So if you have, let's say if you have an object and then you have an applied force, of course the object itself will try to resist this force. So the stiffness is the extent, no? This is the property of a material to resist a force. So we call this our elastic restoring. Yeah, when we apply this to the concept of Hooke's law, this is the elastic restoring force. The force is trying to restore the body or the object to its original or neutral position. Stiffness is the opposite of flexibility or pliability. So, wala siya, no? Flexibility, the object is flexible through the applied forces. Stiffness is that the object resists these forces. Next, the third definition, we have the stiffness of a body is a measure of the resistance offered by an elastic body to a deformation. So, nana po term nga elastic body. So, again, no, we have elastic and plastic. So, elastic gani, mo to kung giingon nga, let's say, no, we have a beam and then if you try to apply a load on that, subutan na to nagkadako ang load, si beam will deflect. So, there is a deflection. Ang symbol ng deflection, no, in your earlier years, it can be symbolized as y or delta or kaninga delta or whatever, no. So, mana siya. And then, unsa man yung elastic body? So, the body is elastic when kung i-try na mag-remove ang force, ubalik siya sa iyang neutral formation. So, that is an elastic body. So, stiffness of a body is a measure of the resistance of an elastic body to a deformation. So, muna na siya, ga-resist siya og deformation si elastic body. So now we have different types of stiffness. No? The first one, we have the bending or transverse stiffness. So kani siya nga kuan, so we have applied forces here, no? Force 1 and force 2, P1 and P2. Of course, these forces will, sa may tabuan ni, it will try to bend the object or the beam. So the bending or transverse stiffness, unsa may na niya, it, of course, it resists bending or deformation due to bending. Or transverse deflection. So, ang general formula ng stiffness is K is equal to EI over L cube. Ang E na to, this is the Young's modulus or the modulus of elasticity. So, balik-balik ka siya, no? Our I is the moment of inertia. And the L is the length of the object. So, remember this general formula. So, ang beams, no, actually, lalahi siya og formula for bending stiffness. It is, of course, also for axial and other. It is because, lalahi pa ng deflection, kada lalahi nga type of beam. Next, we have the axial or longitudinal stiffness. Of course, so as you can see, we have force P here, iyang ginabitad ang member along its longitudinal axis. So, sa ato pa, axial stiffness resists axial deformation. So in other words, no, it resists elongation sa material or compression. That is axial stiffness. So, nailalay nga stiffness. So, pinaka-common yun natong magamit no in our, especially sa atong single degree of freedom nga system is the bending stiffness and then napoy axial stiffness gamay. And panagsa nga torsional stiffness. So, this is the third stiffness nga ko ang i-tackle sa inyo. Ha? This is the torsional stiffness. So, from the name itself, no, nga torsional or torsion, this stiffness, of course, it resists torsion. So, as you can see, no, stiffness is the resistance of a body to an applied force which causes deformation or deflection. So, yung torsion po is that you have a torque here. This is the symbol of the torque T. So, there is a force over that side and then on this side. So, there is a couple. So, this couple will, sa may tabo, iyang mapatuyok ni si, let's say this shaft or cylinder. No? That one. So, torsional stiffness, no, K is just equal, I forgot, no, the actual stiffness, DI, is K is equal to EA over L. So, E again is the modulus of elasticity, or A is the cross-sectional area of the member. And then our L is the length of the member. And then si torsional stiffness, iyang formula K is equal to, we have GJ over L. So what is G? What is J? Or G is, we call this our modulus of rigidity. So kung natin elasticity, nasa tayo rigidity. And then the J is the torsional constant. So of course no, dili gini siya fixed nga formula na pa other formula no atong gina-consider. So ang unit ani ni torsional stiffness is in sa SI is Newton meter per radians. Sa to ang axial or longitudinal stiffness, yung unit is in Newton per meter. And in sa bending and SI, yung unit is in also Newton per meter. Okay. So now we try to relate stiffness no sa spring as per the Hooke's law. So we have here the compound stiffness. Unsa man yung compound stiffness? Of course, it happens when we have we have two or more stiffness sa usa ka system. Like in the di ba, in the single degree of freedom. So we have this system. We have a mass here, and then we have K1 and K2 here. Actually, K1 and K2 dito we have the stiffness due to this column and the stiffness due to this another column. And then napo din tayo katong damper C. So in a single degree freedom system here, we have a compound stiffness because we have two stiffness here. So ato lang na siya gina-resolve into one stiffness. We call that our equivalent stiffness or K equivalent. So mo rin ito, pwede na ito siya ma-model into a lamp mass model like this with a mass and an equivalent stiffness sa iyang column. So sa may naadring as shown in the figure. The figure 1 here shows a stiffness in series. The other one here shows the stiffness or springs in parallel. So kinyong tan-awon no, ang single degree of freedom nga system na to nga building looks like a parallel springs. So anong gina-consider mo nato ni sa series si parallel? What's the importance? It is because series and parallel na sila lahi nga pamaagi pag-solve silang equivalent stiffness and then sa ilading mga ratios and proportions sa ilang deflection. So in a series, again, no, this is the series and then this is a parallel. Sa series, ang equivalent niya nga K is 1 over K equivalent is equal to 1 over K1 plus 1 over stiffness of the second spring hantod sa pinaka-last na stiffness. Whereas in a parallel springs or stiffness, the equivalent stiffness is just equal to the summation of the stiffness na naa dila. Then, ang relationship po nila silang deflection. So we have here the stiffness and then the deflection. Ilang relationship po is that in the series, the deflection is yani yung formula no, force 1 is equal to force 2. Sa ato pa, we have stiffness 1 and then the displacement 1 is equal to stiffness 2 times displacement 2. So here no, atong gigamit nga symbol ni displacement as x. Actually, pwede po na K1 delta 1, K2 delta 2. Or kung sa ato ang previous nga solved nga equations, we have the K1 and then we have the U1 is equal to K2 and U2. So mo siya ang relationship with deflections on a series nga springs. compound spring. Whereas in parallel, ang ilang relationship, the deflection 1 is equal to deflection 2. Of course, klaro kayo, no? They are in parallel. So, kung moisbog ni siya dire to the right, same gid sila og deflection. They are equal. And then, the relationship between their force is like this. The ratio of force 1 to force 2 is equal to the ratio of their stiffness. The ratio of their stiffness. So, if we have F1 over F2, then ang ratio sa stiffness, we have the K1 over K2. Or, F1 over K1 is equal to F2 over K2. So, nganong F1 over K1? It is because of this. Kung sa may naana nga connection. If you remember no, that the Hooke's law, force is equal to Kx. Now, if we have two forces, we have F1 is equal to K1 x1 and F2 is equal to K2 x2. Since x1 and x2 is equal, diba? So we will have x1 is equal to F1 over over K1, and we will have x2 is equal to F2 over K2. So ano lang siya, it is important to determine, so we try to look if the system is in series or in parallel. So na po situation no, mag-combine na siya. Na kay series, and then pag abot na dira na aday parallel. So dili ka mabalaka. Imo lang na siya tagsaon and then mausara na siya. Okay? So we have here no, this is a figure showing the different deflection of a beam. So actually, yung makita dire, this is just a cantilever beam with different types of loading. We have a concentrated force at the end, concentrated force at any point. We have a uniformly distributed force. We also have a uniformly varying force. And we have a moment here. So this is the theta, this is the slope of the deflection. We also have here the deflection at any point. And then we have the maximum deflection symbolized as delta max. So nga naman, unsa may kuan nganong nagpakita man ko og kuan diri kanang symbol or equations for the deflection. It is because the stiffness, diba, is equal to force over deformation or deflection. Or para mas masabtan nato in regards to this, that is just equal to K is equal to P over delta. P over delta. Now, dahil kung na kay P over delta, sa may tabo. So, actually, if you try to familiarize this one, for example, for this cantilever force, for this cantilever rather, yung delta max or deflection max is equal to P L cube over 3EI. Since the stiffness is P over delta, so if we just cross delta on the other side and then the other, so we will have 3EI over L cube is equal to P over delta. Or simply, the stiffness sa atong cantilever beam under concentrated force is equal to 3EI over L cube. So this is very useful because balik-balik niyo siya gagamitin, especially for a single degree of freedom system. Kaya itong gina-consider, di ba nga, dynamic force is a concentrated force. So, kanilang siya, beam lang siya, mura siya nakahigda, but in a single degree of freedom system, di ba, mura gyud na siya beam, nakatindog lang. So, same concept, ato ang gyapong magamit. Okay. So, muna na siya. Familiarize this deflection of formula para mas dali ang pag-apply sa forces. Rather this. And lastly, before we begin with our first example, ato lang dumdumon no this concept on the natural frequency, period, and the amplitude. So last time, di ba, we have already tried discussing we have here the omega, which is equal to the square root of stiffness over the mass. So this is our natural circular frequency. And then its unit is in radians per seconds. We also have our frequency F. This is in omega over 2 pi. So, this is we also call this our natural cyclic frequency. No? Because this is yung unit is in cycles per seconds or hertz. So here, circular. That's why radians, di ba? Because in a circle, ang one rotation is in 2 pi. 2 pi radians. So we have here radians per seconds. And then yung frequency, natural cyclic frequency, that is in cycles per seconds or in hertz. And then we also have our period. The period is just equal to 1 over f. No, that is equal to 2 pi over the natural circular frequency. Yung unit is in seconds. So again, the period is the time it takes. So this is the time it takes for one cycle to occur. So muna siya. So katong total time nga maka-form siya usa ka cycle, we call that our period. So mo lang to siya no, just a very brief introduction before our first example on the application of free vibration response sa simple structures.